So Unit 4 primarily focuses on the vocabulary and the definitions associated with a statistical study. So for that, one of the most important things to know about or to have a clear understanding of is a random sample. And specifically, our definition of a random sample is pretty precise. It's one such that if I'm sampling in order to better understand a population, then within that sample, every member of that population should have an equal chance of being included. So what that means is if I'm talking about, let's say, Delaware Tech students, and I decide to define my population as simply Delaware Tech students, so we're talking about students across the whole state, online students, in-person students. If that's my population, if I am, let's say I go to the Wilmington campus and I go to the cafeteria, ask as many students as I can, that's not really a random sample because now you've got a large part of your defined population that had no chance of being included in the sample. Students at other campuses, students that are never on campus, students that don't use the cafeteria, none of them had a chance at all of being included in the sample. So a random sample is one that takes this definition into consideration. If I was looking to get a random sample of Delaware Tech students, and I'm going to need to travel to all 4 campuses. I'm going to need to find ways to access students that are exclusively online, whether it's email or social media survey. I need to go to various locations within the building. I can't just go to the cafeteria or the library. What about students that never use those facilities? Different days of the week, different times of the day. So it's very difficult to truly meet the criteria of this definition here. And in fact, you could argue perhaps that there really is no such thing as a perfect sample. But the idea is when you're sampling a population, if you want to understand the truth of something, you need a sample that is random as possible. All right, so when we're sampling, there's 2 types of data we discussed. There's categorical data, which describes qualities or attributes rather than quantities. Some examples there. This is categories similar to what you defined in the mid-semester project. Quantitative data is data that can be measured or counted and is expressed numerically. And then one thing that's important to consider here, because I believe the course asks questions like this in the quiz at the very least. Just because it's a number doesn't mean it's necessarily a quantity. So any like identification numbers, my sports jersey, for example, is number 23. That doesn't mean 23 of anything. That's just the number on my jersey that identifies me as a player on the court. Area code, zip code, social security numbers, these are all numbers, but they're not really quantities. Just because I live in the area code 302 doesn't imply 302 of anything. It's just serving as a way to identify the region that I live. So just because it's a number doesn't necessarily mean it's a quantity. All these examples here, age, height, temperature, test scores, sales figures, people at an event, they can all be measured, counted, and can be considered quantitative data. So next up, we've got the types of statistical studies. So there's 2 categories we'll look at. There's the observational studies. This is what you're doing in the mid-semester, end of semester project. We're interested in making observations about a population. So we're just going to observe and collect the data. We're not intending to interfere or manipulate anything. If you want to know how old somebody is and what kind of car they drive, then you would just ask them. Make that observation, record the data, and that amounts to an observational study. An experimental study is more interested in the effects of what's called a treatment. And there is things to look for in an experimental study. Specifically, we've got what's called the treatment, and that is the source of how the researcher would manipulate one of the variables. So for example, you might be interested in the effects of a certain medication on someone's sleep. You're actually introducing a treatment and something that's going to influence or manipulate the variables within the study. I don't want to simply know how many hours a night someone sleeps. We're actually giving them a medicine, we can refer to that as the treatment, and then observing how that medicine affects the amount of sleep. So in order to properly do this, you need to control for certain variables that are can go unnoticed. These are called confounding variables. So the way to do this would to break your sample into two different groups. And we've got the control group and the study group. And the experiment group is the one that receives the treatment. So if we're talking about sleep medication, then this is the group that is going to actually get the medication. One of the confounding variables in a study like this could be what's called the placebo effect. The placebo effect is, in this case, if I were to take a pill, regardless of whether it had medicine in it or not, that could have an influence on my sleep behavior. Just the idea of taking a medicine with the belief or expectation that it's going to help me sleep could be enough to help me sleep better. It has nothing to do with the medicine itself. And that's not what we're trying to measure here. We actually truly want to know, does this medication work to help me sleep better? So in order to control for that variable, we've got two groups. We've got one group, the control group, where the intention is to make the experience as standard as possible, just how are they sleeping well or not. We don't want them to receive the medicine. But we also don't want them to be influenced by this placebo effect. So we would give them a pill, but it would just be a blank pill. Whereas the experimental group is actually truly going to receive that treatment. They're going to get the medicine. But all other experiences across both groups is the same. They're both taking a pill. Neither of them likely know whether it's medicine or not. They probably both assume that it is. But the groups are randomly assigned. There's really no difference between these two groups other than one group gets the treatment and the other one doesn't. And why that's helpful is then when we have the results of the study, we can now make conclusions about the treatment. We can say, hey, experiment group, their sleep got better. Control group, their sleep didn't. The only difference between the two groups is that one got the treatment, the other one didn't. So that means that if this experimental group slept better, it must be the medicine. The medicine must work. Doesn't have to be medicine, of course. This could be really anything. If you want to know how drinking coffee affects someone's performance on a test, you could do something similar. In this case, drinking the coffee would be the treatment. So if you were going to do an experimental study, you'd have two groups. You want one group to just behave as normal. Maybe that means drinking coffee, but you're certainly not telling them to drink coffee. You just behave as normal. And then you've got another group that is actually being told to drink coffee maybe an hour before the test. Everyone in that group is drinking coffee an hour before the test. So their treatment in this case is the prescription to drink coffee, whereas the control group has not been given any prescription at all. They just simply behave as usual. So last up is this idea of statistical bias. And this is on the end of semester project. There's a whole section on, I believe it's question 7, where you're meant to discuss bias in the context of your project. So statistical bias can be thought of as a systematic error in a study or statistical study that causes a model or a statistic to be unrepresentative of the population. So what does that mean? So it means that throughout the study, whether things that went unnoticed or generally bias is not even something that's intentional, just something that a researcher would contend with. So it's something to always be aware of and take steps and measures in order to minimize it as much as possible. Typically, there's going to be bias present on some level in any study. It's very, very difficult to fully eliminate bias. But there are overt categories that the course goes over that really kind of gives us a sense of how bias can affect the study. Response bias, we can also think of it as measurement bias, is a type of bias that affects the data values themselves and how they're recorded or observed. So, for example, if I want to know about someone's favorite sports team and I lead my question with something like, everybody knows the Eagles are the best football team, what's your favorite football team? That could cause a response bias. Maybe their favorite team is the Cowboys, but they know, oh, well, I don't necessarily want to say that now. I don't want to cause conflict or whatever. Or maybe they're not don't have a particularly favorite team, but they say, oh, this guy likes the Eagles, so I guess I'll say the Eagles. Right? That's not what you want. You simply say, what's your favorite football team? Another example of a response bias could be if I'm weighing tomatoes coming out of my garden, if the scale that I'm using is not calibrated correctly, then all of the values that I get are actually different from what they actually are. That would be a response bias. Or if I'm a track coach, so I'm timing my athletes running around the track. If my thumb is not quick enough on and off the button, or maybe the timer itself is defective, that would be a source of response bias or measurement bias. If the survey is not anonymous, like let's say the projects that you're working on, if you included somebody's name, that could potentially be a source of response bias. If someone thinks that their response is not going to be anonymous, particularly if it's like a sensitive question or something, then the answer they give might not be truthful if they know their name's associated with it. Non-response bias is when sample members fail to give information in a study. So for whatever reason, you're looking to get a bunch of sample data and a significant portion of the intended sample doesn't provide information. That could be a source of non-response bias. A good example of this could be maybe I'm calling people up on the phone looking to get their opinion about a particular issue or something. A lot of people, if you call them up on the phone and start asking them survey questions, they're just going to hang up. They're not going to answer. And then what happens is the responses you get end up being people that have a passionate opinion about whatever you're talking about, right? They care enough about the issue to stay on the phone and talk to a stranger that called them up. So all the data you get is actually skewed to that. It's biased by this idea. Everyone that really gave me a response feels really strongly about this issue, when in reality, most people I called didn't even bother to stay on the line. They hung up on me. Another good example would be like in the restaurant industry, they're interested in getting surveys to understand the customer experience. A lot of people, or actually you can even say a majority of people that take the time to fill out these surveys had a negative experience, right? They want to be heard about how terrible their experience was, so they get when they fill out the survey. People that had a good experience are less likely to fill out that survey. So what happens is the data that you're collecting might be biased in favor of saying this restaurant was bad, when in reality maybe most people had a good experience. They just didn't care enough, to fill out the survey. Again, it's the ones that had the bad experience that are motivated to get the survey card and fill it out. So any place where your intended sample has a significant portion of people not providing information, it could be non-response bias. You could even say, though, back to this idea of providing names and having a survey be anonymous. If a survey is not anonymous, then again, if it's a sensitive issue for a particular question that people would have reason to conceal or not want to share, if it's not anonymous, then they might just choose not to participate in the survey. So that could be another way that having an anonymous survey can help reduce bias. Selection bias is probably the most difficult bias to eliminate because it comes back to that idea of a random sample. We had said a random sample is one such that every member of the population has an equal chance of being included. So if your survey is not properly random, then certainly there will be selection bias. A good example of this could be looking to describe Delaware Tech students at large with a sample of students from the Wilmington campus. You got a significant portion of your intended population across all 4 campuses. Only one campus had a chance of being included at all. So you might be misrepresenting the population at large having a sample like that. Even if I went to all 4 campuses and I did my best to be random, tried to go to different parts of the building, tried to send out surveys to access online students, there's still, you can always be more random. There's oftentimes just things that go unnoticed, they're unconsidered, where maybe I asked on a Monday, Wednesday, Friday, but what about the Tuesday, Thursday students? Right. So the larger the sample and the more random, the better. That's how you contend with selection bias. So that's the general top-down perspective on Unit 4. This video needs to be under 15 minutes. I wanted to keep it brief, and the software I'm using only allows for 15 minutes. So hopefully that helps you work through Unit 4. If you have questions, we can certainly address those next week when I'm back. Continue working on the projects and send me any questions you have. Thanks. Take care. Bye.